Okay, so we're back talking about what we did in Math 113 last week, and we are moved on to multiplication. So, first thing we're going to do is talk about a definition for multiplication. So if we have A times B, okay, we're going to say that A is the number of groups that we have, and B is the number of items in each group. And of course, we know that multiplication is commutative, right? So it goes either way. So really, we could talk about it either way. One of them is kind of how many groups, one of them is how many items in each group. We're just going to kind of keep this convention so we have a pattern, okay? So, for example, if I say that there are 3 people in my house and I want to give each person 5 pieces of chocolate, okay, then I have 3 groups, or 3 people would be my groups in this case, right? Times 5 chocolates, 5 items for each person. That's how I get 15. If I want to draw this out, we could say that we have 3 groups or 3 people, and each of those is going to be a row here, and we call this an array. Okay, and this is 3 by 5, right? 3 groups. In this case, each group is the group of chocolate that a person gets. So 3 people, 5 items. So 3 by 5. You can see there are 15 things in that array. So you'll see, last week I posted 2 different modules from the Common Core curriculum that's used in many schools. It's called Engage New York modules. There's some things I like about them, some things I don't. I'll just kind of put that out there. But you'll see that this is what is happening in the schools, okay? So when you look through those, you don't have to look through every single page. They're very long. But they have all of the lessons for that module, kind of a guide for the teachers, the worksheets that are handed out, that kind of thing. One was 3rd grade, one was 4th grade. And you will see exactly what we're going through here, that it is how it's being taught. Okay, so really getting a deeper view. I think that knowing your multiplication facts is important, right? That you need that. You can't be forever, your students can't be forever trying to figure out what 3 times 5 is. They need to know it's 15. But they also need to understand what's happening behind the scenes as well. It's a balance of the two. Okay, so here's my array of 15 chocolates, right? 3 people, 5 chocolates each. All right, so what if instead of this, let's say instead of handing out 5 chocolates to everybody in my house, first I hand out 2 chocolates. So I'm just going to draw a line here. First I hand out 2 chocolates, and then after maybe we all did our chores, then we each get 3 more chocolates. Okay, so I've split it up. So first I did 3 times 2, 3 groups of 2. And then later on, I did 3 groups of 3. Okay. Well, 3 groups of 2 is going to be 6. 3 groups of 3 is going to be 9. Altogether, that's still going to be 15. And you can see visually that I didn't take anything away. I just split it into 2 groups instead of one big group. So if you think about what's really happening here, this is the distributive property. Okay, you might be more used to seeing it written out something like 3 times 2 plus 3, right? Instead of 3 times 5, 3 times 2 plus 3. As you get higher in different math classes, often you would see the distributive property of the variable in there. Okay, but the same idea. You can see visually also there are other ways we could do this. We could instead say, well, I'm going to give out 1 candy first, and then I'm going to give out 4 later. That would be 3 times 1 plus 4, right? It's the same thing. As long as what's in here adds up to 5, then that's fine. And visually, it's really easy to see that. I'm not taking anything away. I'm just moving where my groups are, where my items are grouped, right? 1 chocolate each and then 4. It's the same thing. So we can see the distributive property like this. Okay, so we have these arrays. Now, when we're doing 3 people times 5 chocolate, it's easy to draw that out. Let's say I have a classroom and I have 20 students. And now I want to give them each 12 pencils. Okay, now I could draw it out, but I really don't want to draw out 20 rows with 20 rows with 12 pencils each. So we kind of move to a little more abstract where this is 12 and this is 20. Okay, imagining that I have, here, actually it would be the way around, wouldn't it? Sorry. But here's my 20 students, and they're each getting 12 pencils, right? So here's student 1, student 2, etc. But I'm not going to draw all those out. So we kind of move from the really, really concrete array with your students to then something that's a little bit more abstract, just showing, well, here would be my 20 students, each getting 12 pencils, but we're not going to write all that out. Okay, and we can show distributive property like this also. So we could say, let's say that in September, I give each of those students 6 pencils, and then in January, I give them another 6 pencils for the second part of the year, right? As long as I'm splitting this up so it adds up to 12, that's that distributive property again, 20 times 6 and 20 times 6. Okay, so we've kind of moved from just multiplying, we've gone into the arrays, into the distributive property. So now let's talk about multiplication and the multiplication algorithm. So, standard multiplication algorithm, we know how to multiply. So let's just look at that for a few minutes and kind of think about a little bit of what's happening there. So let's say I have 12 times 8 to start out with here. So we know that we multiply these two. In this case, we get 16. We put a 6 here and put a 1 up here. And then 8 times 1 is 8 plus 1 is 9. Okay, so you know by now probably that I'm going to stop and say what's really happening here. 8 times 2 is 16. Just like any other time that we have 16, this is my 1s and this is my 10s. Similar to when we were adding even. I can't put 16 in one spot. So my 1's place goes there, my 10's place goes up here. Now I have 8 times 1, except I'm going to argue that I'm really not multiplying by 1. So if you think a minute about what I'm going to say we're multiplying by, we're really multiplying by 10, right? So this 1 in this place is very different than a 1 in this place. So 8 times 10 is really what I'm doing. That would be 8 tens, or 80, and then plus one more 10, because this is in the 10 spot, gives me this 9, which is really a 90. So we want to think about where these place values are. Okay, moving on to another step. Let's say I had 12 times 28. So I get my 16, I get my 9. Now, think for a minute in your head. It's probably so automatic you don't think about it, but what do you do right here? This is one of those things that people forget when they're learning. Well, you put, depending on how you were taught, either a 0 there, or sometimes people have put an X in. Either way, this 0 didn't come from multiplying any numbers. This 0, or X, is really a placeholder to move this entire line over. Why are we moving it over? Well, again, because I'm not multiplying 2 here. I'm multiplying 20 times 2. It's not 2 times 2. This 2 is in the tens place. I'm going to cross off that one we carried last time. So it's really 20 times 2. So I have to move everything in this line over to account for the fact that I'm not multiplying by something in the ones place anymore. I'm multiplying by something in the tens place. So 2 times 2 is 4, and 2 times 1 is 2. And then I would add those up. Okay, if I have something where I have 3 places in the bottom, whether this has 3 digits in the top or not, we usually put the longer number on the top, but you don't have to. But here I'd have, 7 times 3 is 21. 7 times 2, which is really a 20, right? 7 times 2 is 14, plus 2 more is 16. 7 times 1 is 7, plus 1 is 8. Put my 0 or my X here, and I move on to the 6. I put that 0 there because now I'm multiplying by something in the tens place. 6 times 3 is 18. This is going to be 13. This is going to be 7. What happens now? Well, I put 2 zeros or 2 X's because now I'm multiplying by something in the hundreds place. So it's not 5 times 3. It's really 500 times 3. So I want my answer to end up in the hundreds. So that's going to give me 15. That's 10 plus 1 is 11. This is 5 plus 1 is 6. All right, then I just add them up. Okay, so we've kind of seen how the place value part is sort of hidden in there, right? We think about two things that are kind of hidden in the standard multiplication algorithm. What we're carrying up here, so what this actual answer is kind of hidden, and then the fact that I'm multiplying by a 20 instead of a 2, this takes it into account, but we don't usually think about it. So we're going to look at a different way to show our multiplication today, and this is called the partial products method. And again, when you look through those lessons, if you haven't already, you will see this in those lessons. And what it does is it kind of brings out all those place values. So let's look at this one. Do it in purple. So 12, because I won't do it in purple. My purple marker's dying. 12 times 8. Partial products, what we're going to do is we're not going to hide those sort of intermediate values we get along the way. We're going to write them right out there. So 8 times 2 is 16. I'm going to write 16 right here. So this is 8 times 2. What do I do next? I do 8 times this 1, except it's not really a 1. Right? Think about what it is. It's a 10. So 8 times that 10 that's represented there is 80. Now I add these up. There's my 96. Okay. So what it does is it gives a much deeper understanding of the place value systems and what I'm doing here. Let's look at it with 2-digit by 2-digit. So we get 12 times 28. If you think about the partial products, I'm going to have 4 parts now. 8 times 2, 8 times the 10, 20 times 2, 20 times 10. Those are going to be my 4 parts. So 8 times 2, every time I multiply something, I just write it down here. I don't have to do any carrying. Next, I'm going to be doing that 8 times 10. So 8 times 10 we know is 80. Then I'm doing this times this. Again, think about what it is. It's 20 times 2. 20 times 2 is 40. How is that accounted for here? Well, there's my 4. My 0 I put in as a placeholder to shove everything over, and then I did 2 times 2 is 4. This took into account the fact that it's really 20 times 2. There's my 40. And then finally, 20 times 10 is 200. Okay. My 0 shoved it over, and then since it was 20, when let's see, what did this be? So 2 times 2 is 4. 2 times 1 is going to be 2. It's really over enough that you can see it's a 200, but we don't really think about it that way. Now I add these up. There's my 6, there's my 13, my 336. Okay, so the partial products, I've pulled that out so I can really see all those place values. All right, this one, if you think about this one, if you want to try this one on your own, you can. I'm not going to do it all right here, but there would be 9 partial products, because 7 gets multiplied by 3 things, 60 gets multiplied by 3 things, 500 gets multiplied by 3 things. Okay, you'll be able to see where they come from because they'll group up to be this. If you think about 16 and 80 made my 96, 40 and my 200 made my 240. Okay, the last thing I want to show you is that you can do that array idea to show the partial products. So if I have, let's see, 12 times 28, okay, I could write it as 12 times 28. All right, I'm actually going to be able to split it up. So I am just about at the end of the time when I can upload a video, the length. So I'm going to stop this one, and we'll do one more just showing how we kind of split these up. Okay, I'll be right back.